So we have a velocity time graph. A velocity time graph, what we can do, we can calculate the distance traveled by an object. We can calculate the displacement. And we can also calculate the acceleration of an object, acceleration or deceleration. To work out the distance or the displacement, what we do, we use area under the graph. Like we'll check what is the shape of the graph and accordingly we'll find the distance traveled. How to work out the acceleration? To work out the acceleration, we have to find the gradient or the slope. So example, in some cases, the distance and the displacement will be same for a velocity time graph. If the direction of an object does not change, it means in that case, the distance and displacement will have the same values. But if the direction changes, in that case, the distance and displacement will have different values. So, example, we have a graph. A velocity time graph. So velocity is on y-axis and the time is there on x-axis. And this is a graph for us. And the question is calculate the distance travel or find the displacement. So we have the numbers, like example of the time axis, it's label 1, 2, 3, 4. And the velocity axis, example 10 is there, 20 is there, and 30. And the question is calculate the distance travel. So if we want to calculate the distance travel or a displacement, in this case, we just take area under the graph. So what is the area under the graph? Because it is making a triangle. So whenever it form a triangle, how to work out the distance travel? It's area under the graph, so it will be half base into height. So in this case, it will be half. What is the base here? 3. And what is the height here? 30. So half 3 multiplied by 30. So 90 divided by 2, we got 45 meters. That is the distance. Because this object does not change the direction, how you identify, does it changes the direction or no? Because we use only the positive y-axis. If we use both positive and the negative axes for the velocity, it means the direction has changed. But in this case, the direction has not changed. So if you want to work out the distance traveled by an object, so these types of graphs in which the direction does not change, the distance and the displacements will have the same values. But what if you have a question in which a direction changes? Is it clear, the first example? How we worked out the distance and that area under the graph will give us the same as the displacement as the direction does not change. But what if we have what if we have a graph in which the direction changes? How we identify the direction change? That in that case, we use both axes. We'll use the positive and the negative. So we have a velocity, positive and a negative velocity. And this is a graph for us. Now the question is calculate the distance and the displacement, and the numbers are labeled example 1, 2, 3, 4, 5, and 6 equally spaced. And we have the y-axis is labeled as well 10, 20, 30, and we have 10, 20, and 30. And now the question is calculate the distance travel and the displacement. So how area, we know area under the graph will give us the distance or the displacement. So in this case, what is the total area under the graph? The shaded region. What is the area of this part? It will be half base because it's making a triangle. So it will be half base into height, which is 30. So we got 45 meters. What about area of this graph? again, it's a triangle, so we'll use a formula half. What is the base here? 1, 2, 3 units are the base, and the height is 30. I'm just taking a magnitude, not the sign. So we got 45 meters again. So if the question is, what is the distance travel? So distance travel will be 45 plus 45. So that is equals to the 90 meters. The distance travel is 90 meters. But what about the displacement? So displacement, because the direction has changed, what does it mean? Like say object was at the origin, it start to move with certain velocity, and then the object changes the direction. So to work out the displacement, what you have to do, you have to subtract the two areas. So if I say area of this was 45 and this 45, so what is the total displacement? 45 minus 45, it's 0. So when the direction changes, you use both axes of the velocity, positive as well as a negative, to work out the area, to work out the distance, you just add the two areas. But if you want to work out the displacement, you have to subtract the two areas. Is it clear, this example, about the distance and the displacement from the velocity time graph? Anyone having a doubt or a question? So first, what was happening? The object speed was increasing and it was moving towards the right hand side. Then the object returned back, like moving in opposite direction. So the direction of the motion has changed. So if this was a positive velocity, like it was plus 10, example, then plus 20 velocity, then plus 30, then this is minus 30, minus 20, or minus 10, and until it reaches a zero velocity. So if we have the total area of moving towards right and left is same, it means the displacement will be zero. So we may have, these are the linear graphs, like this is example in which it is uh, forming a triangle. But what if it is a rectangle? So same way we will do, or a trapezium. So if we have a velocity time graph, so example, if it is a graph like this, so say this is 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And we have 10, 20. This is also negative 10 and negative 20. And the question is calculate the distance travel. So how to work out the distance travel by an object? The distance travel is equals to area under the graph. And we add to get the total. So because it's making a rectangle, so it will be length into width. So it will be 4 multiplied by 20, which is equals to 80 meters. What about the other one? Say this was also the same, 20 was there. So starting from 4, it is ending at 10. So this will be 6, and 26 multiplied by 20, that is equals to 120 meters. Now, what is the distance traveled by this object? The distance travel is area. The sum we will add, like sum of the area. So 80 plus 120, that will make 200 meters. But what about the displacement here? If this is a positive displacement, so it will be plus 80 meter, negative 120 meter. So we got minus 40 meter. Means what does it show? So minus 40 meters, the object actually first move 80 meters towards right, and then object cover total 120 meters towards left. So what is the total displacement of an object from the starting point? So total displacement of this object from a starting point is negative 40 or minus 40. That's how we know that the displacement is negative 40. Is it clear, this example about the distance covered by an object and the displacement? So velocity time
Yes,
graph,
sir.
the distance and the displacement, it will be same if the object does not change the direction. But if the object changes the direction, the distance and the displacement will not have the same value. They will have different values. What if we have a non-linear graph? Like example, an object is not having a constant acceleration like the two examples. The objects was, the first example, it was constant acceleration, and the second, there was no acceleration. But what if the object is having a non-linear acceleration, means acceleration is not constant, and you want to calculate the distance or the displacement? The important thing is how to work out the area, because the same thing, area, like this is a non-linear graph. So for a non-linear graphs, what we will do, and for non-linear graphs, it's always an estimated answer, approximate answer. It's not the exact answer. And different students will get a different answer. So even in exam, they will provide a range of answer for these type of questions. Now we want to find the distance table, but the problem here, it does not make a definite shape, like it does not make a triangle or a rectangle or a trapezium. So for these type of questions, what we have to do for a non-linear graphs, if we want an area, we divide this graph into equal vertical and the horizontal portions. So these are the vertical lines. And these are the horizontal line, equally spaced, horizontal and vertical. Now what it formed, inside it formed the rectangles. So we will count how many rectangles are formed. So this is 1, 2, 3, 4, 5, 6, 7, 8. 8 are the perfect rectangles. But what about the other one? Other, we will see if it is more than half or two together, we'll count them as one. Like example, this is approximation again. So I can say these two together will make one rectangle. Like if I sum them, that's why if I 8 are already there. So if I sum them, I'll get this as 9. Then these two will be 10. What about this one? It looks like more than, so I will consider as 11. So this is again, as I said, it is approximation, it's not exact. So how to work out the total area? So it is a number of the rectangles multiplied by area of each rectangle. So what is the area of each rectangle? Like example, this is 1 and the height was 10. So area of each rectangle was 1 into 10, which was 10. Multiplied by number of the rectangles were 11. So we'll get 11 multiplied by 10. So we'll get 110 meter. But this is again, this is an approximate answer. This is not the exact answer, because for a non-linear graphs, you will not get the exact result. You will always get an approximate result. So for the non-linear graphs, if you want to work out the distance or a displacement, what we have to do, we have to divide the graph into the segments equal horizontal and equal vertical. And after dividing that, count how many rectangles are formed, and then area of each rectangle multiplied by the number of rectangles, you will get the total area, and that will be the distance traveled by an object. If we are using both axes, like example, we are using positive and the y-axis. If we want a distance, we'll add the total area, but if you want displacement, we'll subtract to find the displacement. Is it clear, this one? Yes, Hafsa?
So how are we calculating the distance? This is velocity time graph, not speed.
How we are calculating a distance? Because, for example, if I say an object is moving towards right at a speed of 3 meters per second, and it moved for 2 seconds. So what is the total distance covered by this object? So speed is distance divided by time. So distance speed multiplied by time. So 3 multiplied by 2, that will make 6 meters. So in this case, because the object is not changing the direction, so as the object does not change the direction, the displacement and the distance are the same thing. That's why in exam, instead of speed time graphs, you will have velocity time graphs. Because what is important is the magnitude. We don't bother about the direction. And when you take the area of the graph is a quantity on y-axis multiplied by quantity on x-axis. So on y-axis, we have meters per second. On x-axis, we have second. So when we simplify, so we got the unit as meter. So that's why area of this graph is giving us a parameter of length, which is meter, and length can be distance or a displacement. The only difference between them is the direction. Because we are only bothered about, in case of a distance, we only bother about the magnitude. That's why when we just use the magnitude, we call that as a distance. But when we talk about the direction, we call that as a displacement as well. Is it clear?
Yes, thank you.
How we work out the area of the rectangle? The area of the rectangle is length multiplied by width. So what is the length here of this rectangle? It is starting from 3 and ending at 4. So how long is it? It's 1. And what about the height? It is starting from 0 and ending at 10. So the height is 10. So 1 into 10, that will make 10. And then 10 multiplied by 11, we got 111 meters, which will be the approximate answer. So for non-linear graphs, you will work out in this manner. For the linear graphs, it's because they have the like definite shape and form, so you can easily work out from that. So if I say we have a velocity time graph, so we have a velocity time graph and area of this part is R and area of this part is S. What will be the expression for the distance? What is the expression for the distance travel? Yes,
R plus S.
So the distance travel will be R plus S because the magnitude of this distance plus the magnitude of this distance, we add them, we got the distance travel. But what about the displacement, expression for the displacement?
R minus S.
So that will be R minus S. So we just subtract the two values from each other, area of the two portions, and then we'll get the displacement. If we have a graph, you have velocity time graph. The area of this part is R and area of this part is S. How to get the distance travel? How will get the distance travel? So it will be R plus S. How to get the displacement? How to work out the displacement of this one? R plus S or
S.
R plus S? Because why again R plus S? As the direction does not change. We are only using the positive y-axis. Only one axis. So if you use only one of the axes, the positive or even a negative, then it will always be the sum. Even if there was another graph in which instead of it was above the origin, it was below the origin throughout the motion. So we were having a graph like this. So what will be this graph? So if this is R and this is S, so how to work out the distance travel?
R plus S.
R plus S. And what about the displacement?
R plus S.
R plus S. R plus S. Because we use only one axis. If we have a graph, like example, say, it's not starting from origin, say it's starting with a certain value, and it goes like this. And the question is calculate the distance traveled or the displacement. Remember, it is about area under the graph. What student usually do a mistake is you have to take total area of the graph under the graph. So if I divide into segments, so this is a rectangle, or the full I divided, like I have to take this whole as a rectangle, and this part is a non-linear part. So how to work out the area of this part? I will divide into equal horizontal and the vertical lines. So area of this part plus area of this will get the total distance traveled by an object. So it's area, total area under the graph. So this is how we work out the distance and displacement. Anyone having a question or a doubt? What is the common mistake students used to do here is they are not taking these values. Like example, if a graph starting from here, they are not including this area, but this area should also be included. Even if there's another graph in this manner, so what I have to do, I have to take area under the graph. So I have to take full area. So 1, 2, if I divide into segments, so 1, 2, 3, 4, I have to take the total area under the graph to work out the distance or a displacement. The second part is how to calculate an acceleration for a linear or a non-linear graphs. If you want to work out the acceleration, we have velocity and time graph, and it's a linear, like straight line graph. So the simple way, we take out the gradient. How to work out the gradient? The gradient is that y2 minus y1 over x2 minus x1. So we take the difference, we work out the gradient. For a straight line, you can take any 2 points on the line. Like example, the first point you take, that will be x1. The first point on y-axis will be y1. This is also called a triangle method. So this will be x2 and this will be y2. But for more accurate results, the spacing between the 2 points when you're taking, it should be 5 centimeter or more for accurate results, okay? But it's a straight line. Definitely for a straight line, it is a constant acceleration. So even you take points very close, you will get the same result. But what if we have a non-linear graph? A non-linear graph in which the acceleration is not constant. We have to draw a tangent. We have to draw a tangent at a specific point where we want to determine the acceleration. Say, this is a graph, and we have 1, 2, 3, 4, 5, 6, and so on. And we want to find the acceleration at time is equals to 3 seconds. So how to work out the acceleration at time is equals to 3 seconds? So first you will mark a point on your graph where time is equals to 3 seconds. Then you will draw a tangent through this point. Tangent should only touch that single point. Length of the tangent, it's up to you. Like you can draw long or you can draw short. But as again, I will mention, right, minimum you should draw 5 centimeter in length. And you take 2 points, or you draw the tangent long and take 2.5 centimeter apart. That's also fine. So you can take first point on x-axis of the tangent, that will be x1. The second point will be y1. The first point on y-axis will be y1. You take the second point on x-axis, that will be x2. And the second point on y-axis will be y2. And then use a formula for the gradient, right, which is y2 minus y1 over x2 minus x1. That will give us the acceleration of this object when time is equals to 3 seconds. So because it's a non-linear graph, it means the acceleration is continuously changing. So we draw a tangent at a location or a point where we want to, at a specific location or point, we want to determine the acceleration. So we draw a tangent through that point and work out the gradient of the tangent. For graph, if the slope is increasing, we draw a tangent below. Like example, if we were having a graph like this, say a velocity time graph, and it was like this, and we want to work out the acceleration. So where we will draw a tangent, we'll draw a tangent below this graph. So if the slope is increasing, the tangent will be below. If a slope is decreasing, the tangent will be above. The tangent should not intersect the graph line. It should only touch that single point. Is it clear how we work out the acceleration from a velocity time graph? Anyone having a
Yes.
doubt or question?
No.
Okay. Now we can use this velocity time graph to form a relation as we did yesterday. Like example, this is a displacement time graph and a velocity time graph. If we want to relate, if we have a displacement time graph and we want to relate this with a velocity time graph, so what we do, we check the slope gradient. But if we have a velocity time graph and we want to sketch a displacement time graph, what we do, we use a y-axis. Like, because usually from displacement to velocity is easy as compared to going back to that value. So as you can see here, this is the graph for an object which is, here which is hitting the ground and bounce multiple times. So this is a velocity time graph. This is a negative velocity and here is a positive velocity. So as you can see, what if we were having a velocity time graph and we want to sketch a displacement time graph? So first, what is happening to the value of the velocity? The value of the velocity is, what happened to the value of the velocity? Increasing or decreasing?
Increasing and negative.
So value of the velocity is increasing and it is negative. So means for a displacement time graph, the first part of a graph should be, for a displacement time graph, the first part of the graph, that the slope, because we know as we are using the y-axis and the displacement time graph, the slope represents the velocity. So first section, what should happen? The velocity should increase, but it should be negative. Means the slope should increase and it should be negative. So this is the slope is increasing. As you can see here, when I draw the horizontal line, the slope is increasing. So all these points, the slope is increasing. And what about the slope? The slope is negative as well. Is it clear, the first part? This one, if I say A to B.
Yes.
This is from A to B and this is from A to B. Now, moving from B to C. B to C is a very small, short time interval. What actually happened in B to C, like this object is being dropped, so it hits the ground. How the slope is negative, how we work out the slope is negative, as you draw the line from x-axis, you will get y1. And when you draw the second line, this will be y2. So you can see the y1 is above y2. When the y1 is above y2, it means the slope will be negative. That's why the slope is negative. Now, from B to C, this is from B to C. What happened? This time interval is negligible because what happened when the ball hits the ground, it will bounce back. It changes the direction. So as it changes the direction, it will move upward. Okay. Now, so this section, it's like exactly vertical. So when this is exactly vertical, the time interval is very short, so we ignore this section, the displacement is 0. Yeah, velocity at this point, this point the velocity is 0, because what will happen as the ball is being dropped, the ball will hit the ground. Say the ball was dropped, initial velocity was 0. But when it was hitting the ground, say the velocity is 70 meters per second. But when it hits the ground, momentarily it will be stopped, like because the velocity will decrease and then the velocity will increase as it is going up. So momentarily the velocity will be 0. That's why this part, the velocity at this point, the velocity is 0. So it has like -3, a velocity of -3. Yeah, V will be the highest one as the object is being dropped from a certain height. So U is 0. V is the velocity just before it hits. So just before it hits the ground, the velocity is maximum. Like this is the velocity just before it hits. Then what will happen from B to C when it hits the ground? Because the velocity will decrease and then it will increase in opposite direction. That's why the velocity is decreasing when it hits the ground. It will become like -2. As it is slowed down, the direction is not changing in an impact, and then it rises up. So when the velocity is decreasing, that's why the graph line decreases here. And when it goes up, the velocity will be in the maximum at this point. So that's why we reach this point. Now, what will happen as this ball is rising, as the ball is going up? So first part, the velocity was negative and increasing in this part. It was increasing and negative. So here the displacement time graph, what should happen to the slope? The slope should increase and it should be negative. Then this is a very short time interval. This is the interval here. Now, so this is A, B, C. This is A, B, C. So A is when it is dropped with the initial velocity of 0. You can see A. B is the just before it hits the ground, it will have the maximum velocity. And C is when it start to rise. After hitting the ground, it start to rise. So it will be going up. Like example, going up, we took a positive velocity. That's why C is a positive value. Then moving from C to D, like C to D here. So what happened to the velocity moving from C to D? So if you see the value of the velocity, you take the y-axis. So what happened to the velocity from C to D?
Decreasing.
So velocity is decreasing. So velocity is decreasing. And what about the value of the velocity? It is, we check the y-axis, so it is a positive value. So what should happen from C to D? From C to D, what should happen? The velocity should be like the slope should decrease and it should have a positive value. So this shows that the slope is decreasing and it has a positive value. Is it clear from C to D?
Yes.
Then from D to E, what will happen? From D to E, like this is from D to E, as you can see, whenever what happened to the value of the velocity? The value of the velocity is negative and it is increasing. So what should happen to the slope? The slope should be increasing and negative. So how we represent increasing slope and negative? Again, a similar graph. So that is what happened from D to E. Then from E to F, like this is point E to F, E to F, it bounce off. So when it bounce off, that moment, like it hits the ground and come up. So E to F is this point. So the velocity will decrease to 0 and then it will be the maximum in opposite direction. So this is from E to F. Is it clear? The relation between the displacement time and the velocity time graph for falling object? Any doubt in this? Yes, Hafsa?
Sir, I have a question. Yes.
Yes.
Between the first and the second bounce, how would the ball be?
between the
First and second bounce.
in the first bounce, what happened? If I use a number here, say initial velocity is 0 meter per second. When it reached this point, the final velocity is 3. Then it moves up. The final velocity will, if there is no loss of energy, the final velocity, here it will be the initial velocity -3. So at this point, this was A, this is B, and this one is C. So B was downward, that's why it was a negative velocity. C is upward, that's, or it will be +3 because C is upward. So when it was going down, it hit with a -3. It will stop when it hits the ground and then it bounce back. So it will have a maximum velocity of +3. That is what happened here. So this is -3 meters per second. This is +3 meters per second. But this happened for a very short time interval, which can be neglected. Is it clear? The first bounce?
I mean from C to D and then from D to E.
Okay. So I'll share